Hi, this is Venkat Reddy Reddy. This video is about Python assignment on goldbach conjecture. So let me share my screen. So if you look at the code, this is the code and the output is this. So highlight the main loop in which we iterate over integers 4 to 100. The main loop in this code runs through even integers from 4 to 98 because the goldbach conjecture is applicable to even numbers greater than 2. The loop increments I by 2 in each iteration to ensure that it only considers even numbers. It starts with I at 4 and goes up to 98. Explain the nested loop in which we find two primes to sum to the integer. So the nested loop is not explicitly coded as loop, but it's efficiently handled within the goldbach conjecture function. For I in range 2 comma n quotient of 2 plus 1, as you can see here. This loop iterates from 2 to half of the given even number n. It is responsible for finding pairs of prime numbers I and n minus 1 that sums up to n, as we can see here. If E is prime I and E is prime n minus 1, as we can see, n minus I, within each iteration of loop, it checks whether both I and n minus I are prime numbers by calling the is prime function. If both I and n minus I are prime, it means we have founded a pair of prime numbers that sums up to the given number n, and the function returns this pair as tuple I of I comma n minus I, as we can see here. If loop completes without finding such a pair, it returns none, as we can see here. So, show the discovery of prime numbers. How can we optimize this? So, the is prime function, as we can see here, determines whether a given number n is prime. It uses common optimization technique known as 6k plus or minus 1 rule to check for primality more efficiency. If n is less than or equal to 1, as we can see here, it immediately returns false because prime numbers must be greater than 1. If n is less than or equal to 3, as we can see here, it immediately runs true because 2 and 3 are prime numbers. If n is divisible by 2 or 3, it returns false if either condition is if either condition is met, as these numbers are not primes, then it enters a loop that checks for divisibility by numbers of the form 6k plus or minus 1 up to the square root of n. This optimization avoids checking for divisibility by even and multiple of 3 numbers, as those have been handled. If any of these conditions are met, like I equal to I or I plus 2, it returns false, as you can see here, indicating that n is not a prime. If none of these conditions are met, it returns true, indicating n is a prime, as we can see here. This code is quite efficient in checking for prime numbers due to the optimizations. Thank you.